Welcome to Bemanda Podcast, your frontline source for smart, sharp, and straight talk on IT trends, tech truths, and digital transformation. Here is today's podcast in English.
Ever wished you could, just wave a wand and turn those huge mountains of data into crystal clear insights? Almost instantly.
Right. Or imagine taking those complex, sprawling spreadsheets and transforming them into these beautiful interactive dashboards that actually tell your business's story.
Exactly. It sounds impossible, but honestly, not anymore. Welcome to the deep dive. This is where we cut through all the noise and get you straight to the most important nuggets of knowledge.
And today, we're diving deep into a really crucial mission, mastering Power BI. We're going to unpack how this incredibly powerful tool can basically revolutionize how you understand and interact with your data.
Yeah, and all the insights we'll be sharing today, they come straight from the fantastic Bemanda technology training material on mastering Power BI.
It's a seriously rich resource, really comprehensive. We're excited to guide you through its core teachings.
And by the end of this deep dive, you won't just know about Power BI. You'll have a really practical understanding of its components, how to connect to data, transform it, build powerful models, and crucially, create reports that genuinely drive decisions.
We'll aim for those aha moments, give you practical takeaways you can apply almost immediately.
Okay, let's truly get into mastering Power BI.
It really is true. The journey to becoming genuinely data-driven, it starts with understanding the right tools. And Power BI is, it's undoubtedly one of the most significant ones out there today.
Right.
It empowers you to move beyond those old static reports and really interact with your information, uncovering patterns and insights that, traditional methods often just completely miss. Mm-hmm. It puts powerful analytical capabilities directly into your hands.
So you've definitely heard the buzzwords, right? Data-driven decisions. But how do you actually get there? How do you take those raw numbers, those endless rows and columns, and transform them into strategic insights?
Well, that's precisely where Power BI steps in. At its very core, Power BI is a business analytics tool from Microsoft. It's specifically designed for visualizing data, sharing those insights effectively, and embedding reports right where they're needed most.
Yeah, and what's really powerful, I think, is how Power BI acts as your data's personal translator, and maybe even its artist.
That's a great analogy. It takes the messy, often really raw language of data, all those numbers spread across different systems, and translates it into these beautiful, easy to understand pictures and stories.
Right.
And this transformation, it allows pretty much anyone from, top executives down to operational staff to grasp complex information almost at a glance and make quick, informed decisions.
And it manages this through some pretty incredible key features. We're talking truly dynamic, interactive dashboards and reports. You're not just looking at static pictures.
Definitely not.
Yeah.
And then there's the wide data connectivity. It lets you pull information, whether it's sitting up in the cloud or on your company's own servers, on premises.
Yeah. And it's brilliant at data transformation, too, using tools like Power Query and DAX, which, trust me, we will explore in a lot of depth later.
Oh, yeah. Plus, it even leverages AI and advanced analytics through Azure Machine Learning integration. And it's built from the ground up for collaboration and sharing, whether that's through the Power BI service or even right within Microsoft Teams.
Let's think of a practical use case. Imagine, say, a marketing manager. They need to quickly see how their campaigns are performing across all the different channels.
Okay, yeah, common scenario.
Instead of digging through dozens of spreadsheets and manually putting numbers together, Power BI gives them this single interactive dashboard. It shows real-time engagement, conversion rates, ROI.
Right. Fast, actionable insights from all that disparate data. Allows for immediate strategic adjustments. That's the power.
So how does all this magic happen? Because Power BI isn't just one single piece of software, is it?
Not at all. It's really a comprehensive toolkit, or, like you said earlier, maybe a complete construction kit for building data insights. Each component has a very specific role, and they all work together seamlessly.
Okay, break down the toolkit for us.
Sure. So first, think of Power BI Desktop. That's your blueprint designer, if you will. It's a free Windows-based application where you do the heavy lifting, the data modeling, the extensive transformation, the initial report development.
So this is where the analysts live.
Primarily, yes. Data analysts, developers, this is where they get access to Power Query, DAX, all the visualization tools. So a business analyst, for example, would use Desktop to pull in sales data, clean it up meticulously, design the initial report layouts, define all the calculations before sharing anything.
Right. The real craftsmanship happens there.
Exactly. Then you've got the Power BI service. Think of that as your cloud collaboration hub.
Okay.
This is where you publish, share, and collaborate on those reports you build in desktop.
Yeah.
It's also where you schedule data refreshes, manage your data sets, set up workspaces for your teams.
So the sales manager we talked about, they'd access the reports here.
Precisely. Access published reports, collaborate with their team on sales performance, see updates as they happen. It's the central hub.
Got it. What about on the move?
For that, there's Power BI Modal. It's available on iOS and Android, and it's kind of like having your entire business command center right there in your pocket.
Wow.
You get real-time updates, even push notifications for key alerts, ensures you're always connected to your key metrics no matter where you are. Invaluable for busy execs or, field staff.
Okay, but what if my crucial data isn't in the cloud? What if it's locked down behind our company firewall in our own databases?
Great question. That's exactly where the Power BI Gateway comes in. Consider it like a secure bridge or maybe a drawbridge.
Yeah.
It allows your cloud-based Power BI service to safely access and refresh that data locked behind your company's firewall. It's absolutely essential for securely connecting those on-premises data sources to the Power BI service.
Are there different types?
Yes, there are two main types. A personal gateway, which is more for individual use, maybe testing, and then the enterprise gateway, designed for larger organizational deployments, handling multiple connections securely.
Okay. And what if we have super strict compliance rules, like data cannot leave our building?
For those scenarios, there's the Power BI Report Server. This provides a dedicated on-premises solution specifically for hosting Power BI reports locally. You get full control over your data environment, keeping everything within your own infrastructure.
Perfect for certain industries. And finally,
for developers and software vendors, there's Power BI Embedded. This allows them to embed Power BI reports and dashboards directly into their own custom applications or websites using REST APIs.
so embedding analytics right inside another product.
Exactly. Imagine an ISV, an independent software vendor, embedding Power BI analytics directly into their SaaS product. Their clients get instant interactive insights without ever leaving the application. It's truly insights as a service.
Okay, that's the toolkit. How does it all fit together architecturally? You mentioned layers.
Right, like a well-organized 3-layered cake. Each layer performs a critical function. The first layer, the base, is the data integration layer. This is where Power BI connects to that vast array of diverse sources we mentioned, Excel, SQL, Salesforce, you name it, using its built-in connectors.
And this is where we choose how to connect, like import versus direct query.
Precisely. You make crucial decisions here. Import mode loads data into Power BI's fast in-memory engine for speed. Direct query queries the source in real time, better for huge or constantly changing data sets.
Okay, layer 2, the filling.
The middle layer is the data processing and storage layer. This is where Power Query, powered by its M language, does the heavy lifting of data transformation, cleaning, reshaping, combining.
And the modeling happens here too.
Yes, the magic of data modeling. Defining relationships between tables, creating those crucial DAX measures for business logic. And for that lightning-fast performance, Power BI uses an in-memory engine called Vertipack, which compresses data incredibly well.
And the top layer, the icing.
The top layer is the data presentation and visualization layer. This is where all those rich visual elements come alive. Charts, maps, custom visuals, interactive tables. It's where you build your reports and dashboards and then manage sharing and security, including things like row-level security, RLS, to control who sees what, and integrating with Azure Active Directory for authentication.
Got it. So let's walk through the typical data workflow. It's like a journey for the data. Right?
Exactly. Like a meticulously planned journey to become a beautiful, insightful story. It starts with data collection, using Get Data to connect to your sources.
Then
comes data transformation, happening in the Power Query editor. You clean, reshape, combine, get the data pristine and ready. The prep work.
after it's clean.
It moves to data modeling. This is crucial. Define logical relationships, create DAX calculations, maybe implement RLS. This builds the analytical backbone.
And then the fun part.
Data visualization, designing those interactive reports and dashboards, using all the visuals, making the story take shape.
And once it looks good,
Time for publishing and sharing, usually to the Power BI service, making insights available, enabling collaboration in workspaces.
and it doesn't end there, right?
Definitely not. Finally, there's ongoing data refresh and maintenance. Scheduling automatic refreshes to keep data current, monitoring performance and usage to ensure value over time.
Okay, and deployment. We have options there too.
Yes, the most common is cloud deployment, using the Power BI service. Great for collaboration, scheduled refreshes.
But if security is paramount,
The on-premises deployment, using Power BI Report Server, keeps everything in-house. ideal for regulated industries.
And a mix.
Hybrid deployment gives you the best of both worlds, combining cloud and on-premises data using the Power BI gateway for secure access.
So summing up the good stuff, Power BI's advantages.
Oh, huge advantages. It's incredibly easy to use, has massive data connectivity, powerful real-time analytics capabilities. It's remarkably cost-effective with different tiers, free, pro, premium, and it has enterprise-grade security built in.
But it's not perfect, right? Limitations.
Like any tool, yeah. Import mode can hit limits with truly enormous data sets, although premium helps there. Complex data models need careful design to avoid performance issues. And while visual customization is good, it's not infinitely flexible with built-in visuals, though custom visuals really help bridge that gap.
Okay, makes sense. Before we move on, let's pause for a couple of quick revision questions based on all that. First, imagine your CEO absolutely needs to see real-time sales data, and it's coming from a massive, 5 terabyte SQL database. Which Power BI connectivity mode would you strongly recommend, and why?
Good one. And second, picture this. You've just finished building this absolutely brilliant sales report in Power BI Desktop. What's the very next step you need to take to share it securely with your team for ongoing collaboration, and which specific Power BI component makes this happen?
Think about those, folks. They tie directly back to how these components work together.
So the key takeaway for this whole foundational section.
Power BI is your all-in-one data insights engine, truly, from raw data to shared wisdom. And remember, its components work together like a really well-oiled machine to bring your data story to life.
Okay, so your business data, it's everywhere, right? Scattered across spreadsheets, maybe tucked away in databases, flowing through cloud apps.
It really is. And the real magic of Power BI, the absolute foundation for any comprehensive analysis, starts with its amazing ability to bring all these disparate pieces together, to tell a unified, compelling story from fragmented sources.
Yeah, and a critical part of that is choosing your data road, as you put it, the connectivity modes.
Exactly. Think of these modes like different ways to get water from a well. Each has unique benefits, and each comes with its own trade-offs. You need to pick the right one for the job.
Okay, let's break them down. First up, import mode. You call this the water bucket approach.
That's right. With import mode, Power BI literally imports a copy of your data directly into its super-fast in-memory engine called Vertipack.
So performance is key here. Absolutely. It offers very high performance, making it ideal for really fast interactive reports because the data is right there, optimized.
When would you use this?
Best suited for small to medium data sets where, real-time freshness isn't the absolute top priority. Maybe a small business analyzing last quarter's sales. They can import the data once a week.
What are the downsides?
Well, it's not real-time, right? It needs scheduled refreshes. And there are dataset size limitations, typically 1 gigabit for Power BI Pro, though Premium offers much larger capacities.
Okay, next mode.
Then there's direct query mode. This is like having a live pipeline straight to your data source.
So no importing.
Correct. Instead of importing, Power BI leaves the data in the source system and queries it in real time every time you interact with your report or dashboard.
When is this the go-to?
This is your choice for truly massive data sets, terabytes even, or when you absolutely need up-to-the-second real-time access. Think of a manufacturing plant monitoring live sensor data from production lines. Direct query is essential there.
Pros and cons.
Obvious pros. Real-time data and pretty much no data size limitations because Power BI isn't storing it. The trade-off, performance. It heavily depends on the speed of the underlying source system and your network. And it also has slightly more limited DAX and modeling capabilities compared to import mode.
Gotcha. What about live connection? You mentioned a central reservoir.
Yeah, live connection is similar conceptually to direct query, but it's specifically designed for connecting live to pre-built analytical models. We're talking SQL Server Analysis Services, SSS, Azure Analysis Services, or even existing Power BI datasets that someone else has built and shared.
Ah, so for leveraging existing models.
Exactly. It's ideal for large enterprises that already have these centralized governed data models, maybe in the SAS cubes or shared Power BI datasets. The benefit is fantastic centralized governance, one model serving many reports and no dataset size limits.
The catch.
The main limitation is that you have very little ability to create new measures or calculated columns directly in Power BI Desktop. Most of the logic is already defined in that external analysis services model.
Okay, and the hybrid option. Composite models.
Right. For those who want the best of both worlds, composite models are effectively a hybrid system. They allow you to combine both import mode tables and direct query tables within a single data model.
That sounds flexible.
Incredibly flexible. Perfect for complex scenarios where some data needs to be real-time, like orders, maybe using direct query, while other, more static data, like customer demographics, can be imported monthly for better performance. Composite models also support aggregations, which can really boost performance.
The downside, complexity.
Yeah, they can definitely be more intricate and complex to design and manage effectively. Requires careful planning.
Okay, those are the modes. Now, where does all this data actually come from? You called Power BI a data supermarket.
Pretty much. It can import ingredients from almost any aisle you can imagine.
Right.
Well, you got your common file-based sources, Excel, CSV, XML, JSON, PDF. You can even point it at an entire folder of files for batch processing. Great for ad hoc stuff or combining flat files.
And databases.
Oh yeah, robust database sources. SQL Server, Oracle, MySQL, Azure SQL DB, Amazon Redshift, Google BigQuery, dozens more. These are your heavy lifters for enterprise apps and data warehouses.
Cloud apps.
Absolutely. Extensive online services connections. SharePoint, OneDrive, Dynamics 365, Google Analytics, Salesforce, countless others. Ideal if your organization uses cloud-based business apps.
And Azure.
Definitely. For cloud-native solutions in big data, you have deep integration with Azure services. Azure SQL DB, Data Lake Storage, Blob Storage, Synapse Analytics, and many specialized Azure components.
Can it pull from the web, like APIs?
You bet. You can connect to dynamic web and API sources, pulling data from public URLs, OData feeds, generic REST APIs, or the Microsoft Graph API. Fantastic for custom integrations, or getting live data like stock prices or weather.
And it plays nice with other Microsoft tools.
Seamlessly. Power Platform integrations are key. You can reuse existing Power BI datasets, directly integrate with Power Apps built on your data, and automate complex workflows with Power Automate. It's a truly connected ecosystem.
Okay, beyond direct connections, you mentioned data flows, the cloud-based data prep kitchen.
Right. Data flows are essentially cloud-based ETL extract, transform, load processes. You build them using Power Query online, and they store your clean, transformed data in Azure Data Lake Storage Gen 2.
Why use these instead of doing the cleaning in Power BI desktop?
Great question. Data flows are incredibly useful for centralizing and standardizing your data transformation logic, so it can be reused across multiple reports and teams.
Reusability and consistency.
Exactly. Imagine a large company needing to standardize customer data cleaning names, formatting addresses, before it's used in, say, sales reports, marketing reports, service reports. A data flow defines those cleansing steps once. Then all subsequent reports simply consume that pre-cleaned standardized data. It's a huge time saver, ensures consistency, and seriously reduces the risk of errors across the organization.
Makes perfect sense. What about best practices for connectivity?
Always choose the right connectivity mode for your specific need. Import for speed, direct query for real time. Optimize your data models, minimize unnecessary columns and rows, use a star schema.
Definitely. And for really large data sets, consider enabling incremental refresh so you only load new or changed data, not the whole thing every time.
Crucial tip. And always use gateways for secure connections to on-premises data. If you're hitting APIs, optimize those calls, limit data load, use pagination. These practices keep reports fast and reliable.
Are there common pitfalls or challenges?
Oh, sure. Performance can be a real bottleneck in direct query mode if the source is slow. You might hit API rate limits if you pull external data too often. Data privacy levels can sometimes restrict certain data combinations in unexpected ways. And complex authentication setups can occasionally be tricky during the initial setup.
Okay, let's test our listeners again with a couple of practical revision questions. First one, you have a daily sales transaction log. It's stored in an on-premises SQL server, and it's huge, over 5 TB. You absolutely need real-time updates in your Power BI dashboard for your sales team. Which connectivity mode is your primary choice here, and what specific Power BI component is essential to bridge that on-premises connection securely to the cloud?
Good scenario. And second, your team finds itself constantly performing the exact same set of transformations, like cleaning product names, standardizing region codes, consolidating monthly files on raw Excel spreadsheets before they even start building their individual reports. How could Power BI data flows help standardize this repetitive process, make it much more efficient, and ensure that clean data is reusable for everyone on the team?
Ponder those. They really get to the heart of choosing the right tools. So our key takeaway for this section.
Connecting data is like building your data's nervous system. Choose the right connection type, optimize it, and you'll unlock real power, transforming all those disparate data points into a single, unified, insightful story.
Okay, so you've connected to your data, but let's be honest, raw data in its natural state. It's rarely ready for prime time analysis.
Oh, absolutely not. It's often messy, inconsistent, unstructured, maybe filled with errors or just irrelevant details.
Right. And this is precisely where Power Query steps in. You called it the data's personal digital cleaning crew.
Yeah, or maybe it's Data Sculptor. Imagine you have this rough, unrefined block of marble that's your raw data. Power Query is the tool that carefully chisels, shapes, and refines it, transforming that block into a beautiful, meaningful statue. Clean, structured data ready for deep analysis.
And it's built right in.
Yep, seamlessly embedded into Power BI, Desktop, Excel, and other Microsoft tools. It lets you connect to almost anything, then clean, reshape, and transform that data super efficiently before you even load it for modeling and visualization.
And it's accessible, right? Not just for coders.
Exactly. What's brilliant is that it's largely a low-code and no-code environment. Most transformations can be done with clicks, but, and this is key, it also supports the powerful M language underneath for really advanced custom transformations.
So the workflow, it simplifies ETL. Extract, transform, load.
Perfectly put. First, you extract the data, connect, and import it from your sources. Then comes the transform stage. This is where the real magic happens. Cleaning, filtering, reshaping, handling inconsistencies, structuring the data just right for your analysis needs.
And finally,
you load that beautifully transformed data into your Power BI data model, or maybe into Excel, or even into Power BI data flows for reuse. It's a streamlined and, importantly, repeatable process.
Let's talk about the interface, the Sculptor Studio. What are the key parts?
Okay, quick tour. At the top, you've got the ribbon, packed with common tools, filtering, merging, grouping, changing data types, easy clicks. On the left, the Queries pane lists all your data sources and the queries you're building. In the middle, the large data preview pane shows you your data in real time as you apply each step. You see the impact immediately.
And the most important part for mastery.
Arguably, the Applied Steps pane on the right. This lists every single transformation step you've taken, in order. It's like your underviewed history on steroids.
So you can track everything.
Track, modify, reorder, even delete any step. It's incredibly powerful for refining transformations or debugging issues. And for the advanced users, the formula bar lets you view and directly edit the underlying M code for any selected step.
Okay, what can it actually do? The capabilities, basic stuff first.
Basic cleanup is easy. Remove columns or rows you don't need, rename columns for clarity, change data types, text to number, etc., filter rows based on conditions, sort your data. Standard stuff.
But the advanced capabilities are where it really shines with messy data, right?
Absolutely. You can split columns based on delimiters, positions, even patterns. So separating product name, product ID into 2 columns. Easy.
Merging too.
Yep, merge columns back together. You can group by to aggregate data like getting total sales per region directly in the cleaning phase.
What about reshaping tables? Pivot, unpivot.
Huge. Pivot and unpivot are game changers. Pivoting takes data from long format to wide format like crosstabs. Unpivoting does the reverse, taking wide data and normalizing it into rows, which is usually much better for analysis in Power BI. Think of it like reorganizing a bookshelf from horizontal stacks to vertical columns, or vice versa.
What else?
Replace values to fix typos or standardized terms. Fill down up to propagate values into empty cells below or above. Create entirely new custom columns using formulas written in M.
And combining different data sets?
Yes, you can merge queries, which are essentially joins, inner, outer, left, right, to combine data horizontally based on matching keys. Or append queries, which is like stacking tables vertically, adding more train cars to your data train when they have the same structure, like combining monthly sales files.
Okay, now, M language. You said this is where it gets really interesting. The secret recipe book.
Exactly. Underneath that friendly user interface is this powerful functional language called M, the Power Query formula language. While the visual tools handle maybe 90% of tasks, knowing M lets you tackle those really complex, nuanced, or highly customized transformations the GUI might not expose directly.
What's it like?
It's case sensitive. It often uses a let.in structure. Let defines a sequence of steps or variables, and in return is the final result. Each keyword is super useful for applying operations row by row, and it has a vast library of built-in functions for manipulating tables, text, numbers, dates, everything.
Give us some quick examples.
Sure. Table, select rows, filters rows based on a condition. Table, remove columns, obviously removes columns. Text, replace finds and replaces text within cells. Table, groups data for aggregation. Table, pivot lets you pivot a table programmatically using M code.
Okay, let's make this real. Time for that role-play scenario again. Sarah, the ops manager, and Ben, the analyst.
Let's do it.
As Sarah. Okay, Ben, look. Our monthly supplier report, it's a nightmare. Product codes are buried in these long text strings like widget XYZ1234 and the prices. Sometimes they're text with dollar signs and commas like 54.99 cents. Cleaning it up manually takes forever.
Yes, Ben. Oh, yeah. I see that pattern a lot, Sarah. No problem at all. In Power Query, we can totally handle that automatically. For the product codes, we'll just use split column by delimiter, using the hyphen, grab that last part, easy. And for those prices, we'll use text replace to zap the dollar signs and commas, then just change data type to make them proper numbers. It's like cleaning up a messy pantry before you start cooking. It makes everything usable.
Wait, so you're telling me Power Query can just make our messy data sparkle and do it automatically every single time we get a new report?
As Benedict, exactly. That's the beauty. Once we set up these steps in the Applied Steps pane, every time you hit refresh, Power Query automatically applies this exact cleaning process, saves countless hours, and more importantly, guarantees data consistency across all your reports. It's a lifesaver.
That automation really is a game changer. Okay, so best practices for this data sculpting. Keep it simple.
Keep transformations as simple and efficient as possible, absolutely. And use descriptive step names in that Applied Steps pane. Rename product columns is way better than just renamed columns when you come back later.
Good tip. What else?
Crucially, remove unnecessary columns early in your query process. Why drag along data you don't need? It significantly reduces dataset size and boosts performance.
Right. Less data to process.
Exactly. Always optimize your data types, make sure numbers are numbers, dates are dates, prevents errors, enhances performance, avoid overly complex nested M functions, break down tricky logic into smaller, more readable steps, and whenever possible, leverage Power BI data flows for centralizing and reusing common transformations. Don't reinvent the wheel.
So the big advantages of Power Query.
User-friendly interface makes data prep accessible. Advanced scripting with M gives unparalleled flexibility. It ensures reproducibility since every step is recorded. It automates data refreshes, and it's highly scalable.
Limitations.
Performance can be a constraint with truly massive data sets or extremely complex queries, especially if not optimized well. Advanced error handling often requires dipping into M scripting. And, naturally, it's primarily for batch processing. It doesn't do real-time streaming data natively. You'd need direct query or other tools for that.
Okay, quick revision questions. First, your sales data has a column named sales date time, but you only care about the date part for your analysis. Which specific Power Query transformation would you use, and how does that Applied Steps pane help you manage and verify this change?
And second, you've appended several monthly sales reports. Now you notice inconsistent product names, widgets 1 month, widgets the next. How would Power Query's transformation features help you standardize these names across the entire dataset, and what's the underlying language doing the heavy lifting behind those clicks?
Think about those cleanup tasks. So the key takeaway here.
Power Query is where your raw data gets its essential makeover. It transforms chaos into clarity with precision, using that user-friendly interface backed by the magic of the M language. It turns messy inputs into pristine, analysis-ready assets.
Okay, fantastic. We've connected to our data, we've cleaned it using Power Query, it's sparkling. But data isn't just a collection of clean, separate tables, is it?
Not at all. It's really a web of connections, like a complex family tree, as you said. Building this web correctly, establishing those relationships, that's what data modeling is all about.
Yeah.
And honestly, it's the absolute backbone of any effective Power BI report.
You compared it to a blueprint for a house.
Exactly. A robust data model is the solid blueprint for your data house. Without a well-designed blueprint, your house, meaning your reports and dashboards, will be shaky, hard to navigate, and worse, prone to giving you inaccurate results. A strong model is the foundation for accurate, efficient, and insightful Power BI solutions.
So what are the key components of this blueprint?
At the heart of most good models, you have two primary types of tables. First, fact tables. These contain your quantitative data, the numbers, the measurements you want to analyze, things like sales amounts, revenue figures, order quantities. They record what happened.
Okay, the facts. What else?
Then you have dimension tables. These hold the descriptive attributes related to those facts. Think products, customers, dates, regions. These are your who, what, when, where tables that provide context. A customer dimension might have names, addresses, demographics. A date dimension holds years, quarters, months, days of the week.
And we can add things to these tables, like calculations.
Yes, you can create calculated columns using DAX formulas. These add new columns derived from existing data right into your table. They're calculated row by row when the data refreshes. A simple example is combining first and last names into a full name column.
But there's another type of calculation, measures.
Right, and measures are critically important for analytical power. These are dynamic calculations, also using DAX, but they're computed on demand during report interactions, like when you filter or slice data.
So they're not stored.
Correct. Unlike calculated columns, measures don't consume storage space in your model, which is huge for performance. They're highly optimized for aggregations like total sales, SUM, sales amount. They're flexible and respond dynamically to your report filters. Generally, measures are preferred for any kind of aggregation.
And the glue holding it all together.
The indispensable glue. Relationships. These define how different tables are logically connected, usually based on common columns, like a product ID existing in both a product table and a sales table. They are absolutely essential for combining data across multiple tables in your reports.
Like bridges between islands.
Perfect analogy. Relationships are the sturdy bridges connecting your different data islands, tables, allowing information filters calculations to flow seamlessly and intelligently between them. This lets you slice and dice your sales data by customer region or product category, even though that information lives in separate tables.
Are there different kinds of bridges? Relationship types?
Yes, and understanding them is crucial. The most common, and usually the most efficient, is one-to-many. One. This means a single record in one table, like one unique customer in the customer table, can relate to multiple records in another table, like many orders placed by that customer in the orders table. This is the cornerstone of good modeling.
What about the other way around?
That's many to 1.1, just viewing the same one relationship from the opposite direction. Multiple orders belong to one customer.
What if both sides can have multiple matches, like students and courses?
That's the more complex many-to-many relationship, like a busy highway interchange. Multiple students can enroll in multiple courses. Now, the crucial thing here is that this type of relationship almost always requires a dedicated bridge table or junction table for proper modeling in Power BI.
Why the bridge table?
Because a direct many-to-many link can create ambiguity and lead to incorrect results. The bridge table acts like that central roundabout, containing just the linking keys, student ID and course ID.
Yeah.
It effectively turns one complex many-to-many relationship into two simpler one-to-many relationships, student to bridge, course to bridge, ensuring clarity and accuracy.
Got it. Any other types?
There's also one-to-one, 1.1, less common, but sometimes needed. It's an exclusive link where each row in one table corresponds to exactly one row in another. Maybe a user profile table and a user preferences table. Your preferences are always unique to one user.
Okay, types are clear. What about traffic rules for these bridges? Cardinality and cross-filter direction.
Right. Cardinality just defines how many rows relate the one apart. Cross-filter direction determines how filters propagate between tables.
How filters flow.
Exactly. Single direction is like a one-way street. Filters flow from the one side, like customers, to the many side, like orders. This is generally recommended. It's simpler, often performs better, and avoids ambiguity.
And the alternative, both directions.
Both directions is a two-way street. Filters can flow both ways. You need to use this with caution. It can be necessary for certain advanced DAX patterns, but it can also lead to ambiguity, create unwanted circular dependencies, and potentially hurt performance. Only use it when you absolutely need it and understand the implications.
How do we actually create these relationships in Power BI?
It's pretty easy in a model view in Power BI Desktop. You just drag the key column from one table, usually the one side, like customer ID from customers, and drop it onto the corresponding key column in the other table, like customer ID in the sales table. Power BI is often smart enough to detect the relationship automatically.
Or we can configure them.
Yes, you can then double-click the relationship line to configure the settings: cardinality, cross-filter direction, single, or both, and whether the relationship is active or inactive. Best practice, stick with single direction unless you have very specific reason not to. And make sure your key columns are the right data type.
When designing the whole model, are there recommended styles, architectures?
Absolutely. The star schema is the gold standard, the efficient blueprint highly recommended for Power BI. It has your fact table with numbers in the center, directly linked to surrounding dimension tables with descriptions. This design simplifies queries, boosts performance, and makes the model really intuitive. Think sales fact in the middle, linked out to date, product, customer dimensions.
What about Snowflake?
The Snowflake schema is an extension where dimension tables are further normalized, meaning dimensions link to other dimensions, like a product table linking to a separate category table, which then links to a department table. While it saves a tiny bit of storage space, it creates more complex relationships, requires more joins during queries, and often leads to slower performance in Power BI compared to a well-designed star schema. Stick to star unless you have a very compelling reason.
And bridge tables, we mentioned those for many-to-many.
Right. They're the clean solution for many-to-many, containing just the distinct linking values, turning one complex relationship into two simple one-to-many relationships.
Okay, let's bring DAX back into this. Data analysis expressions. How does it fit into modeling, the engineer's tools?
Precisely. If Power Query is your chef prepping ingredients, DAX is your recipe book. It tells you exactly how to combine those ingredients, apply business logic, and perform calculations to create insightful dishes. It's the formula language for calculated columns, measures, and even custom tables within your model.
Remind us of some common DAX functions.
Sure, you've got your basic aggregations, CM, average, count. Then there's the powerhouse, calculate, which lets you modify the filter context, the ultimate filter controller. Related food pulls values from related one-side tables. Filter lets you filter tables based on conditions within a calculation.
Let's do that scenario again. David, the sales manager, and Emily, the analyst. He needed customer region per order and sales just for the East region.
Right.
As David. Okay, Emily, report looks good, but I need more. Can we get the customer's region listed right next to each order line? And super important for my QBR, can I see total sales only for the East region, like as a separate number, even if I'm filtering the rest of the report by something else?
As Absolutely, David. DAX is perfect for this. For the customer region on each order row, we'll create a DAX calculated column using the related function. It just looks up the region from the related customer table based on the customer ID link. Easy peasy, connects the puzzle pieces. Now for that total East sales figure, we'll create a measure. We'll use calculate, wrapped around our basic sum sales amount measure. Inside calculate, we'll add a filter condition like filter customers region East. This tells Power BI. Calculate the sum of sales, but only for rows where the customer's region is East, temporarily ignoring any other filters on the report for this specific calculation. It's incredibly powerful for focused insights.
As David, wow, so related pulls in details. And calculate lets me override filters to focus on specific slices. That's exactly what I need for the QBR. Genius.
Exactly. Beyond calculations, model optimization is key. Aim to reduce model size, remove unused column tables. Prefer measures over calculated columns for aggregations, saves memory. Use proper data types. Integers beat text for IDs. Use dedicated date tables for time intelligence. And consider pre-aggregating data for huge data sets.
And watch out for common errors.
Definitely. Ambiguous relationships, multiple paths between tables, can cause chaos. Circular dependencies, tables referencing each other in a loop, break things. Incorrect cross-filter direction gives weird results. And inactive relationships won't filter unless you explicitly tell DAX to use them with the use relationship function.
So the absolute best practices for data modeling, quick list.
1. Use star schema. 2. Define relationships clearly, cardinality direction. 3. Use bridge tables for many-to-many. 4. Minimize columns and fact tables. 5. Use measures, not cal columns, for aggregations. 6. Implement RLS for security. 7. Regularly optimize.
Perfect. Okay, 2 revision questions on modeling. First, you have a customers table, unique IDs, and an orders table, transaction details, including customer IDs. How would you set up the most common and robust relationship between them in Power BI? And why is getting this relationship type right so critical for accurate sales reporting?
And second, imagine your sales report is showing really weird totals or unexpected filtering behavior when you slice by product category. What are 2 common data modeling mistakes related to table relationships or filter flow that might be the culprit? And how would you start troubleshooting them in your Power BI model view?
Think relationships. So our key takeaway for this crucial section:
relationships turn raw data tables into insightful stories. Seriously, a well-designed data model is the sturdy backbone of any powerful Power BI report. It ensures your insights are accurate, fast, and reliable. Don't skimp on modeling.
Okay, you've put in the hard yards. You've built your masterpiece report in Power BI desktop. Data's cleaned, modeled, brilliant. DAX measures are in place. Now what? How do you actually share it securely, collaborate with your team, and make sure everyone's looking at the latest, greatest, most accurate information?
Exactly. This is where the Power BI service comes into play. It's your cloud command center for all things collaboration and distribution.
You call desktop the workshop. What's the service? The gallery.
Perfect analogy. If desktop is your personal data workshop, the service is your grand art gallery and collaborative studio. It's a robust, cloud-based platform designed specifically for data visualization, seamless collaboration, and secure sharing of your insights.
What are its key features?
Things like interactive reporting, viewing the reports you build, crucial scheduled data refreshes to keep content current, robust data security, including role-level security, versatile data connectivity, even connecting directly in the cloud sometimes, and extensive collaboration capabilities.
And collaboration happens in workspaces, like project rooms.
Precisely. Workspaces are at the core of collaboration in the service. They are shared environments for managing collections of dashboards, reports, data sets, and data flows. Absolutely essential for organizing your content, controlling who can access what, and facilitating efficient sharing within your team or department.
Are there different kinds of workspaces?
Primarily two. First, there's My Workspace. This is your personal individual sandbox, ideal for drafts, private work, testing things out before you publish them more broadly.
Okay, my personal space. What about for teams?
Then you have shared workspaces. These are specifically designed for team collaboration. This is where you manage content for specific projects, departments, or business functions. It provides that centralized location for all your shared data assets.
And within those shared workspaces, we need to control who does what, right? Roles.
Absolutely. Power BI provides different roles, much like assigning roles in a project team hierarchy, to precisely manage access and permissions. The admin role has full control. They're the project manager. Edge remove members, publish content, manage all settings, the whole shebang.
Okay, who else?
A member can edit and publish content, but they can't manage permissions. Think of them as a senior team member or lead analyst who needs to contribute actively.
What if someone just needs to update existing stuff?
That's the contributor role. They can edit existing content within the workspace, but they're not allowed to publish new content, share things, or alter permissions. Often suitable for junior analysts or specific contributors.
And for people who just need to look.
That's the viewer role. Purely read-only access to reports and dashboards, perfect for stakeholders, executives, or anyone who just needs to consume the information without any risk of changing things.
Let's make that real. Quick role play again. Alex, the marketing head, and Tom, the admin. Alex needs to share the new campaign dashboard.
Sounds good.
As Alex Sec. Okay, Tom. Our new Q3 campaign dashboard is finally ready in the Power BI service. Brilliant. Now I need my whole marketing team to see it. Maria, my reporting analyst, needs to be able to make weekly updates to the data. And the CEO. She just needs to view the key metrics. Definitely don't want her accidentally changing anything. How do I set this up so everyone has exactly the right access without making loads of copies?
As Tom's already taken, no problem at all, Alex. We use workspace roles. For Maria, who needs to update things, we'll give her member access in your marketing workspace. That lets her publish her weekly report updates and refresh the data set. Your CEO, she gets viewer access, sees everything, clicks around, but can't break anything. And for you, Alex, as head of marketing, you'll be an admin. That way you can add new team members if needed, manage data sources, adjust settings. It's all about that role-based access control, giving the right people the right keys.
As Alex M'd. Perfect. So I don't need to lose sleep worrying someone might accidentally delete my beautiful dashboard or mess up the data sources.
As Tom, exactly. Permissions in the Power BI service are like your digital security guards. They enforce who can do what with your valuable data assets, keeping everything safe and sound.
Okay, so beyond assigning roles, what are the main tasks in managing these workspaces?
Well, the initial creation of the workspace, obviously. Meticulously managing members and their permissions over time. Publishing content up from Power BI Desktop into the service. Figuring out the best way to distribute content, often using Power BI apps for a clean end-user experience. And crucially, setting up and monitoring scheduled data refreshes so the data stays current. Plus, ongoing access control and security, like implementing RLS within the dataset settings.
Best practices for managing all this.
Definitely organize your content logically. Use separate workspaces for distinct projects, departments, or maybe even environments like development, testing, and production. That's a really good practice.
Self-test prod, yeah.
Assign roles based strictly on responsibilities for good governance. Keep data governance principles top of mind: security, compliance. Think about version control for your reports and data sets, and perform regular maintenance, periodically review workspace content and access permissions. Clean things up.
Okay, quick revision questions on the service. First, your data analytics team is growing fast. You want new members to be able to contribute by editing and updating existing Power BI reports in a shared workspace, but you absolutely don't want them creating new data sets or changing core workspace settings. Which Power BI workspace role is the most appropriate to assign them, and why?
And second, you've just uploaded a critical daily sales report to the Power BI service. It needs to show fresh data every single morning at 8:00 a.m. without anyone having to manually click refresh. What's the key step you need to take within the Power BI service settings for that data set to make this happen automatically?
Think automation and roles. So our key takeaway for this cloud collaboration hub?
The Power BI service is your shared stage for data insights. Smart workspace management, using roles and features correctly, ensures your data stories are always secure, collaborative, and, crucially, fresh. It empowers your entire organization with reliable information.
Okay, we've connected, we've cleaned with Power Query, we've built our model with relationships. The data structure is solid. But how do we go beyond just simple sums and averages? How do we unlock that deeper, more complex analytical power?
Right. How do you create dynamic calculations that respond to user interaction? Compare time periods, analyze data under different hypothetical conditions.
Exactly, and that's where DAX comes in, right? Data analysis expressions, the language that transforms static data into dynamic insights.
Perfectly said. DAX is truly the data alchemist's language. If Power Query is meticulously shaping and preparing your raw ingredients, DAX is the secret language of recipes you write to combine, transform, and analyze those ingredients dynamically. It lets you create entirely new, calculated metrics that simply don't exist in your source data.
And it's used beyond Power BI.
Yeah, it's also the engine behind Power Pivot for Excel and SQL Server Analysis Services, SSS. It's primarily used for creating calculated columns, measures, and even custom tables. It cleverly combines concepts from familiar Excel formulas with the robust query functionality you'd find in databases.
Okay, let's break down the core DAX concepts again. First, calculated columns, static labels.
Exactly. Think of them as static attributes added right onto your tables. You create them using DAX formulas. They get stored directly in the data model, consuming memory, and they're calculated row by row for each record when the data is refreshed. A simple example is full name, customer's first name, and customer's last name. Useful for static attributes, but not ideal for aggregations.
Why not ideal for aggregation?
Because that's where measures shine. These are your dynamic calculators.
Right, calculated on demand.
Yes. Performed on demand during report interactions when you drag a measure onto a visual or apply a filter. They're calculated at runtime, responding dynamically to the current filter context, and crucially, they don't consume storage space in your data model. This makes them highly efficient for aggregations like total sales, SUM sales amount, or average order value. Measures are almost always preferred for any kind of aggregation.
Can DAX create whole tables too?
It can. For more advanced scenarios, you can create entirely new tables using DAX formulas. These custom tables can be derived from existing data or built from scratch. Useful for intermediate calculation steps or creating specific lookup tables, like finding your top 10 customers. Top customers equals TOPN 10, customers, total sales measure, DESC.
Okay, the tricky concepts, row context versus filter context. Remind us.
Absolutely fundamental. Row context is like reading a book one line at a time. It's the evaluation of a DAX expression row by row, operating on the values in the current row. This is typical for calculated columns.
And filter context, the magnifying glass.
Great analogy. Filter context is much more dynamic. It is like looking at the whole book, but through a magnifying glass focused only on words related to a specific topic. That topic is defined by the filters coming from your report, visuals, slicers, or even other DAX expressions. It's the set of filters currently applied to your data model during a calculation. This is how measures primarily they react to the filter context.
The magic bridge between them. Context transition. You said this is where DAX mastery really happens.
It really is. Context transition is the fascinating process where a row context gets converted into a corresponding filter context. And the main way this happens, by using the calculate function.
So calculate is the key.
It's the absolute cornerstone of advanced DAX. It's like the DAX engine suddenly shifts perspective. It stops looking at just one row and applies a filter across the entire data set based on the values from that original row. Mastering Calculate is arguably the single most important skill in DAX. It unlocks the ability to create incredibly flexible, dynamic measures that answer complex business questions.
Okay, let's talk functions. The Alchemist's toolkit, basic aggregations.
Yep, your standards. SM, average, counts non-blanks, max, MIN. Simple stuff like total orders, count sales order ID.
Logical functions.
IF, switch, like a multi-level IF, AND, or used for setting conditions like sales status, IF, sales amount 1,000, high, low.
And the powerful filter functions.
This is where DAX really flexes. Calculate, the ultimate filter controller, modifying or overriding context. Filters a table based on conditions you specify within a calculation. All, like wiping the slate clean, removes filters from a table or column, essential for things like calculating percentages of a total. And related pulls in values from the one side of a related table.
And the time travel functions, time intelligence.
Oh, yeah. Incredibly powerful. Time intelligence functions are like having a time-traveling calculator built in. They massively simplify complex date-based analysis. But crucially, they require a proper, well-structured date table in your model.
Like what functions?
Things like totally pre-D for year-to-date totals. To easily shift dates forward or backward, like finding last month's sales. Same period last year for spot-on year-over-year comparisons. Parallel period to move across parallel timeframes.
So comparing this month to last year's same month.
DAX Time Intelligence handles that automatically with a simple function call, instead of you trying to figure out complex lookups or offsets. It saves so much time and ensures accuracy for things like rolling 12-month averages or period-over-period growth. And don't forget basic text functions like concatenate or the in symbol left, right, mid for extracting text and search or find.
Okay, let's revisit that roleplay. Chris, the product manager, needs time comparisons. Lena, the BI dev, responds.
Let's do it.
As Chris Lena, my product sales report shows current numbers, which is fine, but I really need context. How did this month's sales stack up against last month's? And what's our year-to-date total looking like? Is there any way to get these comparisons dynamically without me having to manually calculate this stuff every single time I refresh the report?
As Lena, absolutely, Chris. That's exactly what DAX Time Intelligence functions were made for. We can easily create measures like sales last month using data D to shift the date context back 1 month, and sales YTD using totally DD to get that cumulative total from the start of the year. Power BI, with a proper date table, automatically handles all the tricky date logic behind the scenes. It's seriously like having a time-traveling calculator built right into your report.
Wait, so I can just drag these time-traveling measures onto my charts or tables, and they update automatically based on whatever date range I select? That's incredible. That'll make our performance reviews so much easier.
Exactly. Now, beyond the basics, there are more advanced DAX concepts. Really understanding context transition, how Calculate works its magic is key. Understanding virtual tables created in memory by functions like summarize, values, add columns, allows for complex intermediate steps.
And iterators, SMMX, AverageX.
Right. Iterator functions like SMX, AverageX are super powerful but need care. Unlike simple SUM, SUMMX iterates over a table row by row, performs a calculation for each row, and then aggregates the results. So total revenue, SUMMX, sales quantity, sales price, calculates revenue for each sale first, then sums them up. Crucial for calculations involving multiplication or complex logic at the row level.
How do we keep DAX fast? Optimization.
Use measures, not calculated columns. For aggregation saves memory, improves speed.
Yeah.
Minimize complex IF switch, simpler logic is better. Use all and remove filters precisely when needed. Aggregate data at the source if you can. And generally, avoid row-by-row iterators on massive tables if a set-based approach is possible.
Common mistakes to watch for.
Confusing row context and filter context often fixed by using Calculate. Incorrect relationships in the model messing up results. Overusing iterators on huge tables, slowing things down. And watch out for those circular dependency errors that can break your whole model.
Okay, wrap up revision questions for DAX. First, explain the key functional difference between a DAX calculated column and a measure. If you needed to calculate profit margin, revenue cost revenue, when would you choose a calculated column versus a measure, and why?
And second, imagine you have a chart showing sales by product category. You also want to add a comparison line or value that always shows the total sales for all products, completely ignoring any category filter applied by the chart itself. Which core DAX function would you use to create this total measure, and how does it achieve that effect?
Think context. So, the big takeaway for DAX.
Mastering DAX is truly mastering the language of data insight. It's how you elevate your analysis, transforming static numbers into dynamic, powerful answers to drive smarter, context-aware decisions.
Okay, the journey continues. We've gathered our data, cleaned it meticulously, modeled it with precision using relationships, and written brilliant DAX to create powerful calculations. Now, how do we make it sing?
Right. How do you transform all that underlying hard work into visuals that actually captivate people, inform them clearly, and importantly, invite them to explore the data themselves?
This is where building interactive reports and dashboards really brings everything to life.
Absolutely. But first, it's really crucial to understand the difference between a Power BI report and a Power BI dashboard. They serve distinct purposes.
Okay, reports first. The storybook.
Exactly. Think of a Power BI report as a detailed multi-chapter storybook. You can delve into every character, every subplot. Reports are typically multi-page, detailed visual explorations created back in Power BI desktop. They contain various interactive visuals, charts, maps, tables, and they allow for deep drill through informative tooltips, cross-filtering, and lots of custom interactivity.
And dashboards. The scoreboard.
Perfect analogy. A Power BI dashboard is like that quick, high-level scoreboard showing the most important scores at a glance. You can click through to the detailed game report, the underlying Power BI report, if you need more detail. Dashboards are single-page, consolidated views of your most critical metrics. They are created and live exclusively in the Power BI service.
And you can pull visuals from different places onto one dashboard.
Yes. You can pin visuals from multiple different reports, even based on different data sets, onto a single dashboard canvas. This makes them absolutely ideal for tracking top-level KPIs and providing those quick summaries, especially for executives.
Okay, let's walk through building an interactive report. The designer's workflow. Step 1, still data connection.
Always starts there. Step 1, connect to data sources. Import your data, use Power Query for cleaning, best practices, ensure good data types, remove unnecessary columns early, create those relationships.
Step 2, modeling.
Step 2, data modeling. Define those relationships, star schema, create your DAX calculated columns and measures, implement hierarchies for drill down, apply RLS if needed, build that solid foundation.
Step 3, the layout.
Step 3, designing the report layout. Your visual canvas, aim for consistency, plan the structure header, filters, visual areas, best practices. Use grid alignment, don't cram too many visuals onto one page, use consistent colors fonts, keep it clean.
Step 4, adding the visuals. The palette.
Step 4, adding interactive visualizations. Power BI has a huge range of built-in visuals. Your classic bar column charts for comparisons, linear array for trends, Python for proportions, use carefully, cards KPIs for single key metrics.
What else?
Tables matrices for detail, maps for geography, scatter bubble charts for relationships between numbers, and don't forget you can import custom visuals from AppSource for specialized needs. Key practice. Choose the visual that best tells the story for that specific data. Prioritize simplicity.
Step 5 is key, making it interactive. Conversational.
This is where reports come alive. Step 5, implementing interactivity. Use slicers and filters like remote controls for your report, allowing users to dynamically filter data by date, category, region. Apply filters at page, report, or visual level.
And drilling.
Crucial, drill down and drill through. Drill down navigates hierarchies within a visual, year, quarter, month. Drill through lets users jump from a summary visual to a detailed report page, passing the filter context.
Give that sales manager example again.
Sure. Manager sees low sales for widgets category on a summary chart. They can drill down to see sales by specific widget subtypes. Then they can drill through from the widgets bar to a separate detailed page, showing only the individual sales transactions for widgets in that period. Powerful exploration.
What about tooltips and bookmarks?
Tooltips provide extra info on hover, like little whispers. You could even create custom report page tooltips for detailed pop-ups with other visuals. Bookmarks and buttons are like guided tours. Bookmarks save specific report states, filters, visible visuals. Buttons navigate between bookmarks, show hide things, reset filters. And sync slicers ensures filters applied on one page carry over to others.
Okay, step 6. Polishing the masterpiece. Advanced features.
Step 6, enhancing with advanced features. Use conditional formatting like traffic lights for data using color or icons based on values. For AG, sales below target, red, red.
Dynamic titles.
Yes, create dynamic titles using DAX measures so titles change based on user selections. For example, sales report for selected region. Also, custom tooltips, the Q&A visual, ask natural language questions, and smart narratives, AI-generated text summaries.
And finally, step 7, showcasing.
Step 7, publishing and sharing reports. Publish to the Power BI service, set up scheduled refresh, use a gateway for on-prem data, share via workspaces, apps, Teams, SharePoint, email. Manage permissions, apply RLS, optimize for mobile viewing.
And building dashboards is simpler, mostly pinning visuals.
Pretty much. You primarily pin visuals from your published reports onto the dashboard canvas in the service. You can configure tiles, add text, images, web content, and set up data alerts on KPI tiles. Then share the dashboard.
What are the absolute top best practices for both reports and dashboards?
Know your audience. Simplify visuals. Be consistent in design. Use white space effectively. Optimize for performance. Crucial. Ensure data security with RLS. And always check mobile optimization.
Common mistakes to avoid.
Overloading pages less is often more. Using the wrong chart type for the data, ignoring filter context, leading to confusion, and neglecting accessibility for users with disabilities.
And Power BI integrates with other tools.
Tightly. Power Automate for workflows, Power Apps for embedded custom apps, Azure Synapse for big data, is a connected platform.
Okay, time for revision questions on building reports. First, you've created a multi-page sales report. Your users want to click on, say, a specific region in a summary map on page 1 and be taken automatically to a detailed page showing only the sales transactions for that specific region. What Power BI feature would you set up to enable this jump to detail functionality?
And second, your CEO needs a single screen, a high-level overview, showing the absolute most critical KPIs from various different underlying reports, sales, marketing, operations, things like total revenue, customer acquisition costs, on-time delivery %. What Power BI component is best suited for creating this consolidated single pane of glass view? And why is pinning key visuals to it generally better for this purpose than just sharing links to all the individual multi-page reports?
Think focus and context. So our key takeaway for bringing it all together:
interactive reports and dashboards are your data's megaphone. They transform those raw numbers into compelling, actionable stories that empower everyone in your organization to make smarter, faster choices based on real insights.
All right, so the standard visuals in Power BI are fantastic, really powerful. But sometimes they just aren't quite enough to tell your unique data story, right?
Exactly. Sometimes you need something more specialized, maybe more visually striking, something that really pushes the boundaries to highlight a specific, nuanced insight.
And this is where custom visuals and more advanced techniques come into play.
Precisely. Think of the standard visuals as your essential paints at great primary colors, versatile brushes. Custom visuals like those special rare pigments or unique brush types that let you create truly unique masterpieces. They extend Power BI's native capabilities for complex or highly customized business needs.
Benefits being
unique visual appeal, often enhanced interactivity, and the ability to convey specific insights with much greater impact and precision than a standard chart might allow.
Are there different kinds of custom visuals, like safety ratings?
Kind of, yeah. There are certified custom visuals. These are developed and rigorously checked and certified by Microsoft themselves. They pass strict security and performance tests, making them ideal for enterprise use, where security is absolutely paramount.
Okay, certified as safe. What else?
Then you have non-certified custom visuals. These are often created by third-party developers, found in the app source marketplace. They offer huge diversity and innovation, but you need to be a bit more cautious as they haven't necessarily met Microsoft's strictest security or performance standards. You'd want your IT team to vet these.
And we can build our own.
You can. For truly unique or proprietary needs, organizations can develop custom-built visuals in-house using web technologies like TypeScript and visualization libraries like D3.js, leveraging the Power BI SDK, tailored precisely to your needs, but requires development expertise.
What are some popular custom visuals people actually use?
Oh, lots of great ones. The bullet chart is fantastic for performance tracking, comparing an actual value against a target and showing performance ranges, like good, satisfactory, poor. Great for KPIs or budget variance.
Okay.
The KPI indicator visual is another popular one for dynamically displaying key performance indicators, often with trend lines or status icons. The hierarchical tree is great for visualizing org charts or any deep hierarchical data.
What about slicers?
The chiclet slicer is a popular upgrade. It's like a fancy button panel for filtering, letting you use images or custom styles instead of plain text lists. Much better user experience sometimes.
And that map one. Synoptic panel.
The synoptic panel is super cool. It lets you display data directly onto custom images or maps, like building floor plans, seating charts, equipment layouts. Imagine seeing energy usage as a heat map directly on your building's floor plan. That's the synoptic panel.
Wow. Any others?
Histograms for frequency distributions, word clouds for visualizing text feedback, and the radar or spider chart is great for comparing multiple attributes for different items, like evaluating products across speed, reliability, cost, features, all on one visual.
How do we get these into Power BI desktop?
Simple. In the Visualizations pane, click the 3 dots and choose Import a Visual from AppSource. Search, find what you need, click Install, and it appears right there in your Visuals pane, ready to use.
Okay, so custom visuals extend the palette. What about advanced techniques using maybe standard visuals?
Right. They're techniques that add layers of interaction and insight. We've touched on these, but their advanced application is key. drill down and drill through are fundamental for deep exploration.
Tooltips, too.
Sophisticated tooltips, especially report page tooltips that pop up entire mini reports on Hover, provide amazing context. Advanced conditional formatting applied dynamically to charts and matrices brings data to life. Dynamic visuals using bookmarks and buttons enable guided storytelling and interactive interfaces within the report itself.
Sync slicers for consistency.
Crucial for multi-page reports. And then there's things like hierarchies, which you define in your model for easy drill down, and the decomposition tree visual.
What does the decomposition tree do again?
It's fantastic for root cause analysis. It lets you start with a high-level metric, like total sales, and then interactively break it down step by different dimensions. Region, then product, then salesperson, to visually understand what's contributing to that top-level number, like a forensic investigation for your data.
And the AI stuff?
Smart Narratives, the AI storyteller that auto-generates text summaries of your visuals.
Right.
And the Q&A visual, like Google for your data, letting users ask plain English questions and get instant visual answers.
How do we design these advanced visuals effectively? Artistry with purpose.
Exactly. Always choose the right visual for the data and the story. Simplify void clutter, use white space. Apply consistent formatting, use tooltips and labels for context. And critically, optimize for performance, especially with complex custom visuals.
Best practices summary for advanced viz.
Know your audience. Tell a story. Balance simplicity and detail. Test interactivity thoroughly. Optimize the underlying data model. And ensure accessibility. Use colorblind-friendly palettes, clear fonts.
Are there downsides or things to watch out for?
Sure, complex custom visuals can add performance overhead. Compatibility might be an issue, especially on mobile. Non-certified visuals carry potential security risks. And building your own requires significant development effort and has a learning curve.
Okay, revision time first. Your company wants to visualize global sales performance. Specifically, they want to see countries or regions on a world map shaded darker for higher sales, like a heat map effect. Which type of custom visual or advanced technique would you use, and why is it effective for this geographic view?
And second, your executive team loves asking spur-of-the-moment questions about the data, usually in plain English. They don't want to learn DAX or navigate complex filters. Which advanced Power BI visual would you add to your report specifically to cater to this need for direct natural language querying?
Think interaction and specialization. So the key takeaway here:
beyond the basics, custom visuals and advanced techniques empower you to tell more compelling, specialized, and deeply interactive data stories. They make your insights truly unforgettable and drive even smarter actions.
Okay, your data is powerful. Your reports are insightful. But with great power, well, you know the rest.
Comes great responsibility, absolutely. How do you make sure the right people see the right data and, crucially, only the data they're actually authorized to see?
And at the same time, how do you maintain data quality, consistency, and trust across the whole organization?
This is exactly where row-level security, RLS, and a broader data governance framework become absolutely indispensable parts of mastering Power BI. They're the guardians.
Let's start with RLS, the data gatekeeper.
Perfect description. RLS's core purpose is to restrict data access right down at the individual row level based on the user's identity or the roles they've been assigned. It ensures that when user A looks at a report, they might see different rows of data than user B, even though it's the exact same report.
Like a bouncer at a club.
Exactly like a bouncer. Checking IDs against the guest list. RLS lets you build one report but delivers a personalized, secure view to each user.
How does it work? Key components.
First, you define roles in Power BI Desktop. These are custom security roles you create, describing different access levels like East Region Sales Manager or Product Category A Analyst.
Okay, roles define who. How do they filter?
Through DAX filters. For each role, you write a DAX expression that defines the filtering role. It could be simple static RLS, like the rule for the North Region role might just be Region North, hard-coded.
But it can be smarter, dynamic.
Yes, and that's where it gets really powerful. Dynamic RLS adapts based on who logs in. You use DAX functions like username, or more commonly, user principal name, which gets the user's login email. This function is used within a DAX filter rule, often with lookup value, to find the user's specific attributes, like their assigned region or department, from a separate user mapping table you maintain.
So the DAX looks up the user's region.
Exactly. A rule might look like region lookup value, user mapping table region, user mapping table email, user principal name. So when John from the West logs in, the user principal name, part returns his email, the lookup value finds West in the mapping table, and the report automatically filters to show only West region sales. One rule, personalized view for everyone.
How do we set this up?
You define the roles and apply the DAX filters in Power BI Desktop under the Modeling tab at Manage Roles. Then you publish the report to the Power BI service. The final crucial step happens in the service. You go to the dataset security settings and assign your users or security groups from Azure AD to the roles you defined in Desktop.
And testing is vital.
Absolutely critical. Use the View as Role feature in Power BI Desktop before publishing or test in the service to make sure users see exactly what they should and nothing more.
What are the big benefits of RLS?
Huge benefits. Strong data privacy. Massively simplified reports, one report serves many, helps meet compliance requirements, GDPR, HIPAA, and it's scalable, handles lots of users without needing report copies. Dynamic RLS can get complex to configure in intricate models. Poorly written DAX rules can impact report performance. And remember, users with very high permissions, like workspace admins or people with build rights on the dataset, might potentially bypass RLS if other security isn't tight, so it needs careful overall management.
Okay, let's role-play RLS again. Maria, the sales director, needs regional views. David, the security specialist, explains.
Let's do it.
As Maria, David, help. My sales team needs our new dashboard. It's fantastic. But here's the deal. Each regional manager must only see sales data for their own region. I absolutely cannot create and maintain 10 different versions of this report. There must be a better way.
As David Maria, this is a textbook case for row-level security. It's exactly what it's designed for. We'll create just one central report in Power BI Desktop. Inside that report, we'll define a single RLS role. Let's call it Regional Manager. Then we'll write a dynamic DAX filter for that role. This filter will cleverly check the logged-in user's email address using user principal name against a user mapping table we'll set up, which lists each manager and their assigned region. So when John from the West Coast logs in, boom, the report automatically filters to show only West Coast sales. When Sarah from the East logs in, she sees only East Coast data. It's like magic, a personalized view for every single user, all managed from one report.
As Maria, one report, everyone sees only their slice automatically. That's brilliant. That saves so much time and headache and keeps everything compliant.
Exactly. And RLS is really just one powerful component of the much broader concept of data governance.
A data constitution.
Great way to put it. Data governance is that comprehensive framework of processes, clearly defined roles, established policies, and robust standards. It ensures the effective management, high quality, stringent security, and full compliance of your data assets across the entire organization. It sets the rules of the road for data.
What are the main pillars of governance?
Things like clear data ownership, who's responsible, dedicated data stewardship, who ensures quality, robust policies and standards, how data is handled, adherence to compliance and security regulations, and comprehensive metadata management, documenting and understanding your data.
How does this apply specifically within Power BI?
Several ways. Using data classification and sensitivity labels, like confidential, from Microsoft Purview to tag reports and data sets for secure sharing. Leveraging data flows and shared data sets to centralize data prep and ensure consistency. Implementing structured workspace management, DevTestProd, RBAC.
What else?
Using data lineage and impact analysis features to see how data flows and what a change might affect. Robust auditing and monitoring via Power BI audit logs and usage metrics. And integrating with broader compliance tools like Microsoft Purview for unified governance.
Benefits of doing all this governance work.
Immense. Better data quality and consistency, enhanced security and privacy, easier regulatory compliance, greater operational efficiency, and ultimately building trustworthy data that everyone relies on for decisions.
Challenges. It sounds like a lot of work.
It can be complex to implement initially. You might face cultural resistance. Ensuring it scales takes effort, and it requires continuous monitoring and adaptation. It's an ongoing commitment.
And RLS and governance work together.
Hand in hand. RLS is the technical enforcement mechanism for the access control policies defined by your governance framework. They're intrinsically linked for ensuring data protection, privacy, and integrity.
What tools help with both in Power BI?
Deployment pipelines for safe promotion. The Power BI REST API for automation. Azure Active Directory, AAD, for authentication and RBAC. Microsoft Purview for cataloging, classification, lineage. And Power BI audit logs for monitoring.
Okay, final revision questions for this critical area. First, your company handles highly sensitive customer financial data. Compliance rules state sales reps can only see data for their own assigned customers. How would you implement this restriction in Power BI, and what specific DAX function is essential for making this access dynamic based on the logged-in user?
And second, Beyond just restricting data views with RLS, why is establishing a broader data governance framework so important for an organization using Power BI heavily? Name 2 key benefits this framework brings specifically to improving data quality and building trust in the insights coming from Power BI reports.
Think security and trust. So our key takeaway.
RLS and data governance are the indispensable guardians of your data. They ensure security, compliance, and trust, making sure every insight you generate is not only powerful, but also properly protected and reliable.
Okay, we've explored all the individual pillars. Connecting, cleaning with Power Query, modeling with relationships, calculating with DAX, visualizing, sharing. Now let's bring it all together. Let's walk through the full end-to-end process of actually building a Power BI report from that very first piece of raw data all the way to a published interactive insight.
Exactly. Think of this as the complete project lifecycle for turning data into actionable intelligence. Following a structured approach like this ensures efficiency, accuracy, and ultimately a successful report.
So phase 1, back to the beginning.
Always starts with phase 1, data connection. Gathering your ingredients. Identify all the data sources you need, files, databases, cloud services, APIs, and connect to them in Power BI Desktop using Get Data.
Give us an example scenario.
Sure. Maybe a new business initiative needs you to combine current sales data from a SQL database with marketing campaign data from various Excel spreadsheets, and maybe website visitor data pulled from Google Analytics. This first phase is all about getting those different ingredients successfully into Power BI.
Phase 2, the prep work.
Phase 2, data preparation. This is where you launch the Power Query editor and do your cleaning and transformation, removing duplicates, replacing values, splitting or merging columns, maybe creating calculated columns using M language, getting everything pristine.
Like cleaning and chopping the ingredients.
Perfect analogy. Clean, chop, organize everything before you start cooking. You might also use Power BI data flows here for centralized, reusable transformations if you have common cleaning steps needed across multiple reports.
Phase 3, the recipe structure.
Phase 3, data modeling. This is arguably the most critical analytical step. Establish robust relationships between your tables, ideally a star schema. Normalize your data. Create your dynamic measures and maybe some calculated columns using DAX to embed all your business logic and calculations, like total sales or profit margin. Implement hierarchies for drill down. Apply row-level security, RLS, if needed. This phase creates the logical structure of your analysis.
Phase 4, presentation.
Phase 4, data visualization. Now you choose your visuals. Charts, tables, cards, maps, custom visuals. Add essential elements like legends, labels, tooltips. Use slicers and filters for interactivity. Maybe use bookmarks and buttons for navigation or storytelling. Apply consistent themes and formatting.
Like plating the meal beautifully.
Exactly. Imagine building an executive dashboard. Use KPI cards for headlines, a line chart for trends, a column chart for comparisons, slicers for filtering. Make it visually appealing and easy to consume.
And the final phase, serving it up.
Phase 5, publishing and sharing reports. Serve your meal. Publish your completed and tested report to the Power BI service. Set up scheduled data refresh, using a gateway if needed for on-prem data. Share reports and dashboards with users or groups, maybe via Power BI apps. Manage permissions and RLS. Make it accessible.
What about best practices throughout this whole flow? Modeling.
Data modeling. Star schema preferred. Minimize columns. Use measures over calculated columns for aggregations. Reduce relationship cardinality where possible.
Visualization.
Visualization. Choose appropriate visuals. Limit clutter. Highlight key insights. Be consistent with colors fonts. Provide intuitive interactivity.
Performance.
Performance optimization. Optimize Power Query steps. Aggregate data if feasible. Limit direct query use. Monitor using Performance Analyzer. Be efficient.
Are there advanced report features we should aim for?
Masters often use drill-through pages for detail, custom tooltips for context, bookmarks and selections for dynamic views, dynamic titles and measures using DAX, and integrating custom visuals for specific needs.
And deployment, moving from development to production.
Use deployment pipelines, dev, test, test, prod, for controlled releases. Monitor usage with usage metrics in the service. Practice good updating and version control. Document your changes.
What if we hit problems? Troubleshooting, slow reports.
Slow performance. Optimize the model. Reduce visual complexity. Use aggregations. Data, not refreshing. Check schedules, gateway status, credentials. Overloaded reports. Simplify. Use drill-through, split content, complex relationships. Revisit modeling. Aim for star schema. Use bridge tables. User access issues. Check workspace permissions and RLS rules carefully.
Okay, 2 final revision questions on the end-to-end process. First, You've connected to your data and done some initial cleaning in Power Query. What are the next two critical phases you would move into, in sequence, to prepare this data for meaningful analysis and then start creating visual insights?
And second, your beautiful new report is becoming noticeably sluggish as data grows. Name two specific best practices, one related to data modeling and one related to visualization, that you would apply immediately to optimize its performance and improve the user experience.
Think workflow and efficiency, our key takeaway for the whole process.
Building a Power BI report is a journey that combines precision and artistry. It's about ensuring every step, from connection to visualization, contributes to a clear, actionable story that empowers decision makers effectively and efficiently.
Okay, final section. Let's talk about those old reports. Do you have Excel monstrosities gathering digital dust, requiring hours of manual updates every week or month?
Or maybe folders full of old CSV files that are just a pain to analyze because they're so static.
It's time for an upgrade. This section is all about transforming those static, often cumbersome legacy reports into dynamic, insightful Power BI powerhouses.
It really is an upgrade that can change everything. Moving from, say, a manual typewriter to a super-powered digital content studio. Benefits are huge.
Such as?
Advanced data visualization, interactive, customizable, real-time dashboards. Automated data refresh slashes manual effort, reduces errors. Significant scalability and performance, handles much larger data sets much faster than Excel ever could.
More connections, too.
Right. Integration with multiple data sources, SQL, SharePoint, Azure, APIs, not just files. And, critically, enhanced security and sharing with RLS and seamless distribution.
But we need to prepare first, the pre-flight checklist.
Absolutely crucial. Step 1. Assess existing reports. Identify your critical legacy reports. Understand their purpose, complexity, usage. Document their data sources, formulas, especially complex ones, pivot tables, macros. Know what you're replacing.
Step 2. Clean up.
Step 2. Clean and organize data. Before bringing it into Power BI, remove junk columns rows, fix inconsistent formatting, dates, numbers, and get rid of those dreaded merged cells. Power BI needs clean, tabular data.
Step 3. Requirements.
Step 3. Define reporting requirements. Talk to the users. What business questions does the new Power BI report need to answer? What are the KPIs? What decisions will it drive? Plan the visuals. This ensures the migration delivers actual value.
Okay, let's focus on migrating Excel first. Options.
Several good ones. Option 1, direct import. Simple connection to the Excel file. Select the sheets or tables. Easy for basic data.
What if the Excel file already uses Power Pivot or Power Query?
Option 2, import pivot tables and Power Query. Power BI can often directly import those existing data models from Excel. Huge time saver if the groundwork was already done there.
And for automatic updates.
Option 3, connect to Excel and Power BI service. Upload the Excel file to OneDrive or SharePoint first, then connect to it from the Power BI service. This enables scheduled refresh, keeping your report updated automatically from the cloud-hosted file.
What about migrating other types? CSVs, SQL Web?
Similar principles, CSV as flat files. Use get data text CSV, configure delimiters, clean in Power Query, SQL databases. Get data SQL Server, provide credentials, select tables, model relationships, web APIs. Get data web, provide your URL endpoint, use Power Query to parse the results.
Once the legacy data is connected, what's the key transformation step?
Data transformation and modeling is critical. You'll likely need significant data cleaning in Power Query, removing empty rows, splitting columns, replacing values, maybe unpivoting data from cross-tab formats.
And modeling is still vital.
Absolutely. Define relationships. Normalize into a star schema. Then, crucially, recreate the logic from old Excel formulas using DAX measures. This is where you build your total fails, profit margin, variance calculations, etc. Implement hierarchies and RLS.
Let's do that finance director role play again. Sarah's painful budget versus actuals Excel report. Mark the consultant offers the Power BI solution.
Right.
As Sarah, Mark, honestly, our monthly budget versus actuals report, it's killing us. It's still in Excel, drowning in VLOOKUPs, requires manually consolidated sheets from different years, hours of updates every month. Can Power BI really automate this and make it interactive? I'm skeptical.
As Mark. Absolutely, Sarah. Classic migration candidate. First, we'll pull your Excel budget file and all those actuals 2023, actuals 2024 sheets into Power BI. Then, the magic happens in Power Query. We'll perform an unpivot operation to consolidate all those separate annual actual sheets into one long, clean, continuous table. No more manual consolidation. After that, we build a solid data model with a proper date table, linking budget and actuals. Finally, we use DAX measures to calculate your variances dynamically and maybe add some cool conditional formatting to instantly highlight over-under budget items. Zero VLOOKUPs needed, and it updates automatically.
Wait, it takes away all that manual pain and gives me a live interactive view I can drill into. That's not just an upgrade, that's a transformation for our finance team.
Once modeled, it's report design visualization. Choose your visuals, add filter slicers, maybe drill through pages, use bookmarks buttons for interaction, apply consistent themes.
And finally, publish and share.
Publish to Power BI service, schedule the refresh, use gateway if source files are on-prem, share the report app, manage permissions. The usual final steps.
Key best practices for these migrations.
Simplify models, star schema, use measures, not calc columns, optimize performance, remove unused stuff, implement error handling in Power Query, document everything, secure the data, RLS, DLP.
Common challenges and solutions. Complex Excel formulas.
Recreate with DAX. Performance issues. Optimize the model visuals. Refresh failures. Check gateway credentials. Manual data entry steps. Automate with Power Apps Forms APIs. Report overload. Simplify. Focus on KPIs.
So, a quick example workflow. Excel sales report to Power BI.
1. Connect to Excel. 2. Clean in Power Query. Remove blanks. Split. 3. Model link sales products regions. 4. Create measures. Total sales, margin via DAX. 5. Design visuals. Charts, slicers, KPIs. 6. Publish and schedule refresh. Done.
Okay, final 2 revision questions ever. First, you have a critical legacy Excel report. It relies heavily on complex VBA macros for calculations and has tons of hidden sheets used for lookups. What are 2 absolutely crucial preparation steps you should take before you even open Power BI Desktop to start migrating it?
And second, after migrating your Excel report, you realize a key complex calculation from Excel, maybe involving multiple IFs, VLOOKUPs, and SUMIFs, isn't working correctly when you try to replicate it directly. What 2 specific Power BI features or languages would you primarily turn to in order to recreate this complex business logic effectively and robustly?
Think, prep, and logic. So our final key takeaway from migrations.
Migrating legacy reports to Power BI isn't just a technical upgrade, it's a strategic leap. It moves you into dynamic, automated, and deeply insightful decision-making, transforming that static old data into a living, breathing, valuable asset. #tag outro.
Wow, what an incredible deep dive that was. Today, we have seriously journeyed through the entire amazing world of Power BI. And huge thanks for the guidance from the insights in the Bemanda technology training material.
It really covers the ground, doesn't it? We explored the core architecture, unlocked the secrets of data connectivity, harnessed the really transformative power of Power Query for cleaning data.
Built those robust data models with relationships and DAX, crafted interactive reports and dashboards that actually tell a story.
Yeah, and we even looked at securing your sensitive data with row-level security, and just now, how to breathe new life into those old static reports, migrating them into this dynamic new world.
So hopefully you now have a really solid understanding of how Power BI acts as your data's own personal translator, its artist, and its guardian. It empowers you to move from that raw, often disconnected data to confident, actionable insights.
Absolutely. Remember, true mastery really comes from seamlessly connecting, meticulously cleaning, intelligently modeling, thoughtfully visualizing, and securely sharing your data. It's all about telling those powerful, compelling data stories.
So the big question for you, the listener, is, with all this incredible power now, hopefully clearer at your fingertips, what's your next data challenge? What old, dusty spreadsheet are you going to bring to vibrant, interactive life?
And what new, maybe even game-changing insights will you uncover that could transform how you or your organization make decisions? The data really is just waiting for you to tell its story.
Keep exploring, keep asking questions, and keep transforming your data.
We genuinely can't wait to see what amazing things you build with Power BI.